So yesterday we spent a lot of time trying to set up our R environment. So today we are just going to go straight into what we intended to do yesterday before we had those mishaps along the way. So I'll quickly open my R Studios actually. I'll open my R Studios. So I have all the script here today. So we just run them. I'll show you what exactly what is it that I'm writing or we are doing. Then you run it alongside with me, and then we move on. So yesterday, I asked you guys to create a folder on the desktop while we kept the R script inside. Actually, that is not how we create a project. Okay. What I asked you to do yesterday is something that most of us do when we want to start a project, you want to do data analysis, you go to your desktop, you create a folder, you put your files inside. But in R, there's a special way to do that so that R can actually organize your files for you. So we have a structure, okay? You have a structure. We have the main folder, okay? We call it the main directory. Then the main folder contains three other folders. One of the folder contains the raw data. The other folder contains the R scripts. And the last folder contains what we call the output. So along the way, if you are creating graphs, you are sending certain outputs, you save them, those graphs, tables, and all those things, you save them in the output. Your script folder contains the script, and your data folder contains the data. That is how we organize our project. Okay, that's how we organize the project. It is done in that way so that if I want to send the work that I've done to somebody, I can just send the whole folder. I can just send the whole folder to the person. And the person doesn't really need to change his or her directory in order to access those files. So that's what I want to show you today. So that particular folder that we created at the desktop, I think is R for data science, R for underscore data underscore science, something like that. So I am now coming to teach you how to create the folder, okay, how to create a project folder appropriately. So at the left top corner, you can see we have file here, okay. In fact, I want you to close everything. That small script that is at the top there, close it, let it go. Then we have this, okay. I believe many of you have this, but because we opened a script yesterday, you should have a script here. What I just closed, you should have your script here. So I want you to look at the top. There's some X button at the name of the script, and then you close it. Then you should have a blank page like this. So since nobody complained, I believe that we are on course. So now, for you to create a project file, you have to go to File, the top left corner, the top there, top left corner. You go to File.
Yeah, hello, Ken.
Yes.
Please, I'm here to close my script. Please, if you can take me back.
Did you close the script? Are you able to close?
No.
Look at the top here. Let me open the script. In fact, let me close my whole R.
Okay.
You have a folder we created yesterday, R for data
Yeah.
science.
Yes, please.
I click it. That file we were working on yesterday is inside
Okay.
because I asked you to put it inside.
Oh, okay.
So I double click it. It opened R for me. So you have something like this. Even though my script is different from yours, but you should have something like this. True? Do you have it?
No, I've not run it yet.
Please
I
be
don't
snappy.
have it. Then let me do it right away.
And since we have video recordings, I think I'll limit the rate at which I go back on certain things. Other than that, we are not going to progress.
Exactly.
Sister, have you opened it?
Yes, please, we can go on now.
Now look here. Look at my cursor to the top here. You see this? This is the name of the file. Okay, this is the name of the file. We name it something different. Okay. I don't know, my hand touches and it's left. What is the name of the file? Yesterday we named it something different. How did you name it?
Introduction. Something.
Exactly, introduction to R. I need you to close it. There's a close button at the edge of the name of the file. You close it, and you should have your screen like this. So I believe that is done.
Mr. Kinsley, the file I have, my patient's data file I have is an Excel document. It's not R.
So when you open R, what did you see? If
Nothing.
the script you created yesterday, why did you save it?
The script I created yesterday,
And
the
then,
introduction
yes,
script
yes. Why did you save it?
in the patient health, in the R4 data science.
So you should have two files there. I sent one file on WhatsApp, which is an Excel file. I asked you to put it inside that folder, and the script we created yesterday should also be in that folder, right? Feedback.
Yes,
Yeah, but
but that file is an Excel file.
Mhm.
The patient health data is an Excel
It's an
file.
Excel file. We are not touching that data yet. But the script we created yesterday, the introduction to R, why did you save it?
In that folder, the R4 data science.
You have it there?
Yes.
So the sister, I'm actually talking to the sister who was asking the question. So the guy talking, if you have the R script in that folder, just double click on the R script. It will open the whole R for you, R Studio for you. And that is what I want the sister to do. So I'm asking the sister if you have saved your R script yesterday in that particular folder. Have you?
I have, it's in there. You opened something with a lot of syntax scripts, but
That one,
I don't have that.
no, that you don't have to worry about that.
Okay, all right,
This
that's
thing,
fine.
this particular thing here, patient health doesn't really concern you. You should have an R script you wrote yesterday, which you label introduction to R, right?
Yeah. Mhm.
I need you to double click on that one. It will open R for you. Okay? Just forget about what is here. When you open it, you should have introduction to R at the top here.
Mhm.
Do you have that?
Yeah.
So I need you to close it. You see, there's some small X here. I need you to close it. Right? When you close it, this is what you see. Feedback.
Yeah.
All right, so we are creating a project folder. So you go to File, over here, the top here, the top left corner, you go to File. You see, initially we were doing new file, we go to script, but now we'll go to File and go to New Project. New Project, New Project. So you click on New Project. When you click on New Project, this window will open for you here. Ideally, if we hadn't created that folder, that R for data science, ideally, if we hadn't created that folder, we'll go to new, we have to go for new directory, okay? So now follow me, new directory. The new directory, then you click on new project, right? Then you give it a name, that name R for data science, R for data science. You write it here, R for data science, right? Then you create a project. But because we have created another folder, this particular folder already at the desktop, we will not do it this way. But if you are starting a new project, okay, a new project, which is, let's say, anemia analysis, you have to create another folder for that particular analysis, another project. Let's imagine that we don't want to do, we want to ignore the R for data science. Okay, let's ignore it. Let's name this particular folder. So let's name it health. Please create it. We'll move the files from that particular folder to this particular folder. Name it health data analysis. Okay, please name it like that. I'm with you. Can I move on? From here, I'm not going back. Let me cancel the whole thing and start over again for the last time. I need you to go to File, you go to New Project. Then you go to New Directory, okay? What do you need? You need a new project. You click on it. What is the project name? The project name is Health Data Analysis. Okay, this is a parent folder you are creating, a parent folder, like that R for data science we created. Now we are ignoring that folder completely. So after here, when you name your main directory, your bigger folder, okay, your project folder, Health Data Analysis, I need you to click Create Project like this. Is it done?
Yes, sir.
Yes, yes.
All right. So now, over here, the environment tab, here. I need you to click on File. You see, you click on File, and you see R project. You see a file name .r project. Okay, we have environment, history. I need you to click on File because it's files we are looking at. Files. So you have R project. Okay, Health Data Analysis .r project.
Mm,
Do we have it?
yeah.
Yeah.
Now, that is the parent directory. See, what you have here, what you have here is what is making R look at that folder as a project folder, but not the ordinary folder that we've been creating at the desktop. So this, you don't really have to understand, but once you instantiate that process as an R project process, it will create this file for you automatically. Now, within this particular folder, we need 3 other subfolders. We need a folder that will contain our raw data. We need a folder that will contain our R scripts. We need a folder that will contain our output like graphs, tables, and all those things. So under this same file, I need you to click on New Folder here, New Folder, and name that folder Data. You click OK. Let's go. Please do it.
Yeah.
I believe you have done it. You need another folder called Script.
Mhm.
And lastly, what do we need? Another folder called
Good.
Output. Do we understand this concept? Do we understand the concept? So if you collect your raw data, you come and put it in this folder. The script you'll be writing, you save it in this folder. Your graph and everything, you send it in this folder. Now, let me show you something. I'll close the R. Close the R. And we will not have the need for this R project again, but we'll move files to that place. So now, this is what we created, Health Data Analysis. Okay. When I open it, have you seen all the folders we created? You've seen all the folders we created. And if you want to go back to that R project, this file that was created, this particular file that was created automatically by R, you just have to click on it. It will take you back to the whole project. Have you seen it?
Yeah.
So it sees the whole file as a project. So it will load it for you. Now, what I want start to do here, I'm closing the arrow again. You see this, the old folder that we created. Let's put the data set I sent to you into the data folder. You drag it, or if you can copy, okay? Control C, copy, and then I put it in the data folder. I go back, and this is R scripts. Control C, I put it in the script folder. You get it? Then I can confidently delete this folder that have the R4 data science folder. I don't need it again because I have a project folder. Yes.
Please, when I open the folder, I don't have them in my folder.
If you open which folder,
The R4 data science folder,
you don't have what inside?
I don't have the new folders we created on the R there.
We didn't create that folder inside R4 data science. When I open R here, when I open R, I told you to name that thing as health data analysis. Do you remember?
Yes.
Do you remember?
Yes.
Did you do it?
Yes, I did.
So look for that particular folder, health data analysis. Look for it at your desktop.
Oh, okay. Desktop rather. Well, data analysis.
Have you seen it?
Mm.
You can search it. Maybe you didn't save it in your desktop.
Yeah, I found it.
Why is it at the desktop?
No, I searched it as someone just.
Do you have the files inside?
No.
No?
Mm.
Open R. Okay, open R.
Okay, so do I close the R, the initial one where we created the health data analysis, the output script data. Do I close that one?
When we were doing this, I closed the whole R and I passed you through the process, right?
Oh, okay.
So where are you now? Where are you lost? So that I can start
Okay.
that place.
Well, I'm closing it. I just closed it.
Open it back.
Yeah.
Please just give me feedback. It is opened.
Yes, it's opened.
Go to File, top left corner. Click on it. Go with me. File. You tell
Yes,
when you're there. Tell me you are there.
I'm there.
New folder. New project.
I'm there.
Click on it.
Yeah.
Did you see what I'm saying? New project wizard. Did you see it? What is on my screen? Have you seen it?
Yes.
I need you to click on new directory.
Yes.
Click on new project.
Yes.
Give it the name health underscore data underscore analysis in that directory name. Make sure that look down there. Did you see the tilde/desktop? Did you see it?
No, mine is, yes, it's just that.
Tilde.
Yes, I don't have the desktop there.
So, sister, just name, let's one by one. Type
Oh,
health underscore data underscore analysis. Type it for me first.
analysis, I'm done.
You are done.
Yes, please.
Now click on browse. Okay.
Okay, browse.
Can you locate your desktop and click
Yes.
browse? You should look for a folder that is named desktop.
Yes, I've clicked on desktop.
So you can click now on OK.
Okay, open. Okay.
Have you seen the tilde/desktop now?
Yes, mine is C/users/PC/desktop.
Okay, so the tilde actually takes away all those long things that you have mentioned. So that is fine. Now click on create project.
Okay.
Did you
Done.
run? Did it run? It ran, right?
Yes, it's run.
Now, over here, I think you can see my mouse. On the
Yes.
left-hand side, the
Mm.
bottom window, we have environment, correct?
Yes.
History, correct?
Yes.
Now stay on file. Click on file.
Yes, I'm there.
Have you seen something inside health underscore data underscore analysis dot rproj?
Yes, it's there.
Now we are on course. Now that you are there, that is the parent or the root directory, right?
Right.
I need you to click on new folder, which you can see at the top there, the yellow folder plus plus.
Yeah, new folder.
A window should open for you.
Yes.
Type data.
Okay. Data. Done.
Okay, click again. Type script.
Scripts. Done.
Click again. Type output.
Output. Done.
You have it. Okay. Forget about this history. These are hidden files. Okay. Some of you, your computer may not allow you to show hidden files. So just forget about this. So, sister, I need you to close R, or everybody,
Okay.
you close R. You remember that folder we created yesterday, R for data science. You remember? We have,
Yes.
we have, we have two files inside. We have two. One is an Excel sheet that I sent on WhatsApp. Do you remember? Do you have it there?
Yes.
I need you to move that file to the data folder in the health data analysis folder. Copy the data, the Excel file there, and place in the data folder. Is the instruction clear?
Oh, okay.
Can you do it?
Yes.
Right click, copy.
Okay. Sure.
Now move to that health underscore data analysis folder. Locate the data folder, open it, right click, paste.
Okay. It's done. It's pasted.
Now, there's a script you created yesterday, which was called Introduction to R. Do you remember?
Yes.
It should be in that folder, R for data science. It should be inside. Is it?
Please, is it the same as the R history?
No, it's not the same as the R history. It's named Introduction to R.
Okay, I don't have that.
That's fine. Now, let's all move to R. So, sister, click on, now that you're in this folder, the health data analysis, just double click on health data analysis.R project. It will open the whole project for you in R.
Mm.
Are we together now? Are we together? I just need you to click on the health underscore data underscore analysis.R
Yeah.
pro, and it will open the whole R for you.
Okay.
In any circumstance, if you're not seeing the files, either you're at environment, history, plot, packages, help. If you want to see the files, it's under files. So that is it. So now, that being said, I have programmed my R script already, but because I need you to type what I'm showing you, please go to File. Okay, go to File. Go to File and go to New. Go to R script like this. Okay, please do that. You should have this. You should have this.
Mm.
If the action is taken, please let me know so that I don't wait. Yes, yes.
Yes, so the files are two. So which of the file are you talking about? The top left-hand corner or the file where the environment is?
The file at the top, where we save
Oh,
file, yeah, file. I expect that.
okay. So
File,
file edit, so we should go to file, right?
yeah, file at the top, the left top corner. Okay, file.
Okay.
You select
Okay.
R script, R script, R script. It will open for you. Now,
R script, okay.
yes.
Is that we should select R script, right?
Yes, R script.
Okay.
R script. Now, I need you to go to File. Again, you are saving this R script. And this time you go to File, you click on Save As. Save As. Like the way we've been saving our Word document, right? Save As. Save As. Then you locate, you remember that script data, script folder we created. You remember? Locate it and save it inside. Okay? Locate it and save it inside. Am I making sense? Are we making progress? Because
Yes, sir. But sir, what name should we save the data in the script?
are you all here so that I'll show you?
Okay.
Are you all here?
Kingsley,
Yes, sir.
I think I had a little network connection. I dropped off where the gentleman was asking which file, whether the one on the top left or the one under the result area.
One at the top left.
So, yeah, please take it from there. Okay.
The one at, so are you with me? The one at the top left.
Yes, I'm with you. Yes, I'm with you.
Okay, good. Somebody says, I say, what is not showing from the top?
The file and all those things. The file there,
How possible? Which operating system are you using? So at times you have to send your, if you're using Windows, at times you have to send your cursor there, then it will drop for you to see. Okay? At times some of those things disappear. You have to send your folder there, depending on the operating system you're using. But the file I'm talking about is the top left corner, File. Then you save as. Okay? You save as. Now, where are you saving? You are saving in that script folder we created. Okay? And you are saving the file as patient health data, just like the data set name, patient health data. It has an R extension. You leave it, you don't delete it. I need you to save it like this. But make sure that you locate that project folder, which contains data, which contains output, which contains scripts, and make sure that you save it in the script folder. Is the instruction clear? Yes.
So please forgive me. So catch me. So I just want to be with you guys. The lights just went off briefly and came back. So I followed up to file where we took file and we took R scripts.
Okay. So that means that
Yes,
your R script have been created and you have untitled at the top left corner there, right?
Yes, on title, yes.
Now follow me. You go back to that the file at the left hand side, at the left top corner.
Okay.
Click on Save As.
Save As, okay.
Locate that project folder we have created, that project folder. Okay?
Okay.
The one that has
project health data analysis.
Exactly.
Okay.
Now track the small folders inside then save the script on the script inside the script folder. But I want you to name that script patient_health data and save it inside the script folder. In the instruction,
patient. Yeah, it's clear. Patient underscore
health
underscore data. Okay. And save it inside the script, right?
Yes, and it comes with an R extension. Don't delete it.
Okay.
All right. Okay. So I believe that. So you click save, and then it will save inside that folder. So I believe that all of us are here now. I believe all of us are here. So we'll start there. We'll start what we are supposed to do today.
Okay.
You have an issue? Do you have an issue?
Yes, please. I followed twice. I couldn't do that.
You followed twice to where?
That's with the. So yes, so I opened file, then I went to save as.
Save as, file
Yes.
save as. It should
Yes.
open a window for you, right? File. First of all, did you create the R script first? File, new R script. Did you do that first?
Yes, I did.
So you are seeing untitled at the top left corner, right?
No, Yes, Untitled 1. Yes.
Yeah, that's what I mean. Now we have to save this R script in that small folders we created, the one we name script. Do you remember? Do you remember that folder?
Yes, I do.
So now let's go to File. In fact,
Yeah.
for the last time, Save As.
Yes.
Then a window should come up for you, right?
Yes.
Do you know how to navigate folders? Where are you? Can you see? I don't know if
I
you
can see data, output, and script.
exactly. So now, first of all, rename the untitled.r to patient underscore health what? Patient underscore health underscore data. Please do it. Patient
Underscore health underscore
data.
data. Done.
Now wait. Go and click on the script folder.
Yes.
Now you can save it inside there. Click on save.
It's open rather, not. Okay, I got it.
Good.
Mine is also open, so I was confused.
So once it's saved, you should be here. Because I have already programmed my script. When I open my script, don't confuse it with what you have there. I have the codes inside. You don't have the codes inside. So I'll be running my codes and I'll tell you what the code is doing, and you will be writing it as a practice. Are we together? Do we understand?
Yes.
Yes.
So I am opening my script, which anything you see there should not bother you. This is my script. So now we are starting. Yesterday, we created what we call objects. Okay, other people may call it variable depending on where you are coming from. In R, we call it objects. Okay, we created objects. I'll run through that and then we move on. I believe that yesterday we all got hold of the using R as a calculator. 2 plus 2, 2 minus 3. We talk about PEMDAX, okay, parentheses, exponents, multiplication, division, addition, and subtraction in that order. In primary school, we call it board mass, but we are grown now, okay? We are grown now, so we move away from board mass to PEMDAX. That is what the order of importance when it comes to mathematical operations. So we look at that. We evaluated numbers in brackets and then multiplication and all that. So this is what I want to quickly rush you through, because this was what we did yesterday before we couldn't have enough time on our side to finish. Yesterday, we talked about object. I want you to see object. I spoke about this yesterday, so I'll just rush through it. Imagine a cup, okay? You have a cup, and then you put 20 pesos inside that cup. And that cup, you have to label the cup 20 pesos, okay? So if you need that 20 pesos, where will you get the 20 pesos from? I need an answer. You have a cup. In fact, you have a yellow cup, and then you put 20 pesos inside that cup. If you need the 20 pesos, where will you get it from?
In the cup.
From the cup.
Exactly.
Yellow cup.
In the yellow cup. In the yellow cup. So I like the answer in the yellow cup because you can have different cups. That yellow cup, let's assume the cup is labeled yellow cup. If you need your 20 pesos, you have to go and take the yellow cup because it contains the 20 pesos. I need you to understand this because a lot of people use SPSS. A lot of people are used to SPSS. So these concepts have not been really explained because SPSS lets you do things without even knowing what you are doing. Once you know how to click and get output, you are cool. But when it comes to these programming languages, you have to understand exactly what you are doing. And these things open your mind. So now, the concept I just explained. So this is the 25, okay? And I have a container.
Just a quick one. Are we supposed to also have like what we did yesterday showing on our screen?
No, because we created
the blank is fine.
A blank
screen. A blank screen. Okay. All right, just to be sure. Thank you.
Yes. So now, from the beginning to this place, I taught you how to create a project file, and that is the standard in everything you do data analysis. You follow that standard. Now we are talking about object, and I use a cap as an example, and somebody say yellow cap. Now I have an age of an individual, okay? I have age of Kofi, which is what, 25 years. In this software, the 25 as an age. You cannot be going and be putting 25, 25, 25. You have to assign this 25 to an object so that anytime you need a 25, you carry the object and the object will spill out the age for you or the 25 for you. So yesterday, this assignment operator here, I don't know Windows, how I forgot the combination of keys you use, but on MacBook, it's Option and then the negative sign, okay? Option and the negative sign. I think Windows, somebody said it was Alt and the negative sign. Am I correct?
Alt enter.
Yes.
Alt
Alt minus.
Alt minus.
Alt minus, yeah.
That will give you this sign. You can't go about and be doing this and this, okay? By the time you finish, it's evening. So now we have this age for Kofi. So we are saying that take this age and put it inside this bucket that we call age. So anytime I need the age of Kofi, okay, now I put this age inside this bucket called age. So look here, the console. Look at the console. Anytime I need the age of Kofi, I just have to carry that particular bucket or that particular object and I run it, it will spill the age of Kofi for me, 25. Does it make sense? It's a repetition of what we did yesterday. Quickly, and I'll move on.
Yes, please.
Now, yesterday, we also look at height and weight. And you know that this thing that we are writing here, height and weight, if you have a full data set, somebody's mic is making some noise. If you have a full data set, this is how you actually reference the variables in the data set, but with a little bit tweaking, which I'll show you. So we have weight in kg. The weight of this Kofi guy, the weight is 70. So take Kofi's weight, 70, and assign it to this container, which I label weight in kg. Good? So, and you know that you have to run it. If you don't run it, it will not work. You have to run it. So you have the weight of 70 assigned to this label, okay, this bucket. So anytime you need the weight, you click on it, you run it, you get the weight 70. At the same time, we have the height of Kofi, which is 1.7, right? So we assign this 1.7 of height in meters to this object, which we name height. And the objects have to be a reflection of exactly what we are doing. You can't have weight in your mind. This is weight, okay? This is weight. Then you go and put K here. The variable have to explain or reflect what you are trying to describe. So the weight is 1.7 meters. You run it. If you want to see what is inside the weight, you click on it and then you run it. It gives 1.7. Okay. And then yesterday, somebody raised a concern that, oh, I have used equal to sign and then it works for me fine. Yes, it will work for you. For example, temperature is equal to 38.2 degrees Celsius. It ran, and if you call temperature, you get the 38.2 at the console. It works. But it's a standard practice that in R, we use this particular symbol. So don't use the equal to, even though it will work for you. Don't use it. Don't use it. So this rather assign. It gives you that mental picture, okay, or that mental graphics that I'm taking 1.75 and I'm putting it into height in meters. Okay, that is why they adopt this standard. Now, yesterday we look at how to calculate BMI because we have weight in kg and height in meters. We know the formula for BMI is equal to weight in kg divided by height in meters squared. Now that we have those two variables, okay, if this were a data set or if this was a data set, we pick the weight of everybody, we pick the height of everybody. We should be able to calculate BMI for individuals by just running we create the name of the variable which does not exist. BMI does not exist in the data set. So because we are now altering, okay, or we are creating a new variable into the data set, we give it a name, and the name is BMI, body mass index. Now, this BMI is equal to, as you may think of it, okay, or this BMI, the formula is weight in kg divided by height in meters square. You know, we have our weight in kg, which is represented by 70, okay, and the 70 is stored here. And then we have height, 1.75, which is stored here. And when we're doing mathematical operations, I told you that the exponent, okay, is that shift, you will have shift and then 6, that particular symbol on 6 on your keyboard. That gives you this. That gives you this. If you are so much have time, you can as well do, for example, after all, you are doing height in meters square, you can create a variable height in meters square, okay, is this height in meters, height in meters, okay, times height in meters, right? Height in meters. That gives you height in meters square. So you can assign this to this height in meters square, like this. You run it. So now, instead of doing this BMI is equal to, or BMI to the assignment of this, because you have height in meters square variable already created, you don't need this height in meters raised to the power squared, because you have already created a height in meters square, and then you put it here. You run it, okay? You run it. You have your BMI. So once you run your BMI, you see that the BMI should give you 22.857 or 22.9 approximately. Does that make sense?
Yes.
Yeah.
Good. These little things that we are doing, somebody may say that we are here for data analysis, draw graph, do this. These things come handy when you are faced with a larger data set. So just understand. Now we have another example. We are looking at malaria positivity rate, okay? And what is the formula for malaria positivity rate? Isan, malaria project manager. Malaria positivity rate is equal to those who test positive, okay, over the total tested, okay? That is how we calculate malaria positivity rate. So now, we created a variable or an object, which is positive test, okay? Out of 100 people that were tested, 38 of them test positive. So positive tests are 38. So we assign 38 to positivity. Then the total number of cases that were tested, 100. So we assign it like this. Like this, we assign it and then we run it. Now, if they asked you to calculate malaria positivity rate, domain knowledge, you should know the formula for malaria positivity rate, which is the number of people who tested positive over the total number of people who were tested. That gives you malaria positivity rate. So if you know how to combine all these things together, you know how to use the R to write this. Now, we are creating an object, which is malaria positivity rate, underscores. Okay, we'll look at proper naming of variables, what not to do when you think that you are naming variable and what to do. So I have malaria positivity rate. Now, what is the formula for malaria positivity rate? As I said, this is a formula for malaria positivity rate. And this represents the values. Positive cases, 38. The total number of cases tested, okay, 100. So this object or these containers will spill out these numbers. Then we'll assign it to the malaria positivity rate, right? So if I run this code, and now this calculations is saved in this object. Now, if you want to see the calculation, you call the object, you bring it back and you run it. So the malaria positivity rate is 38%. Are we making sense?
Yes.
Good.
Yes.
I want to hear from our ladies.
Yes, please.
Good. Your own is important for me, Pa. Now, let's look at naming conventions, okay? Naming conventions. There are standard ways that we name variables. One is called camel case. Camel case. It starts with, for example, if I want to name, let's say if my name were a variable, camel case will ask you to do Kingsley in under the first one, Kingsley, and then you bring capital letter. Then you bring my surname. So you see that it takes the shape of a camel. You see, camel starts it have a flat surface. At a point in time, it goes up and come down again. Are you getting the picture I'm trying to create? We call it camel casing. You start with capital letter. Let's say positivity. Then you bring capital rate. Okay. So those are two words that you are joining together. So you start with capital letters. If the next word want to start, you start with a capital letter. It starts with a small letter. And if the next word want to start, you start with a capital letter. We call it a camel casing. You can adopt this strategy in naming your variables and make sure that whichever strategy you adopt, you are consistent. Okay? You are consistent. Then we have the snake. And mostly what we've been doing so far is the snake. Okay? You chain it with underscore. So this one is the snake. So in this tutorial, we are going to keep to the snake naming convention, whereby you separate words with underscores when we are creating a variable. Now, it is important that if you want to create variables, the name that we assign to those variables should be meaningful. Okay? You will not have a variable that is talking about weight, then you go and name the variable. You will not have an object that should be talking about weight, then you go and name it K. It doesn't make sense. The name of the variable should reflect what the variable actually means. So you should give it meaningful names. Always maintain lower cases. Always maintain lower cases. You can use underscore to separate the words, and that is the snake format. And you do not start a variable naming by number. You can't say you are naming a variable and say 7 sex. It will not work. You get an error. Okay. You do not start a variable name with numbers, and don't use spaces in, for example, please, the person whose microphone is on, please take care of it. You do not include space in your variable names. For example, malaria positivity rate. You don't do this. You don't do it. You don't do this. We don't name variables like this. If you want to do this, connect them with the underscores, okay? Then you should avoid special characters, okay? You can't name your variable something like this or something like this, okay? Or factorial. You can't do that. Avoid them. So these are good examples. For example, patient underscore age, okay? Patient underscore age is a good naming convention, okay? We join the age with an underscore. Malaria cases, good naming convention. Facility name, okay? Facility underscore name, good naming conventions. Avoid very long names, okay? Truncate the name. Just let it make sense. Okay, facility name, Tamale Central Hospital. These are good ways by which you can name your variables or your objects. Let's look at the bad names, okay? What is one age? One age. It will not run. You have an error. What is patient space age assigned to 34? This is a bad way of naming a variable. It will not even work. The malaria dash cases. You don't name variables like this. Okay. Okay. Are we over this? Do you understand?
Yes.
Good.
Yes, sir. But
yes.
We are sticking to the snake.
Exactly.
Okay.
All your life, stick snake.
Okay, sir.
Your variables should be lower cases. If you know that, in your mind, you program yourself to understand that anytime I'm doing data analysis, when I'm calling variables, it should always be lower cases. Now let's look at, R is case sensitive. Most of the statistical softwares are case sensitive. So these three examples I gave here, an age starting with capital A is different from age starting with small a, and is different from age all caps. Don't think that because in your mind, age is just age, you can write it anyhow, and then the software will understand what you are doing. You get an error. The way in which you label your object should be the same way you reference those objects. So for example, if you have age, which is 30, capital A, which is 30, and this one, small letters, which is 25, and capital H, which is 40, this will produce different results for you because this will give you what it was assigned to. This one will produce this for you, okay? And this one will produce the other for you. The lesson here is that be consistent. In fact, don't think that capital H, you can just use small h to call capital H. It will not work. R respects casing. Okay, we say R is case sensitive. I think the lesson here is clear. Okay, don't use small a, G, E and go and be looking for capital A, G, E. It doesn't work that way. So R is case sensitive. Now, in many statistical package.
Hello, Kingsley.
Yes.
And before you proceed, so I've been following till now and I'm okay. But then, because yesterday I was a bit behind, I still don't know how to do that sign. I was using the equal to, but you mentioned that one is not very recognized with R. That's is it less than dash? Yes. I don't know how to get that one.
I get it. Which operating system are you using? MacBook or Windows?
Please, it's Windows.
Windows, somebody said it's what? Alt and then the negative sign. Alt and the negative sign.
Okay. Okay, thank you.
Did it work? Please do it.
Okay. Let me. Okay.
Your hand should be on the Alt key. Then you press the negative sign, which is at the top of your keyboard, top left, top right corner, somewhere around there.
Yes.
Did it work?
Yes, it worked. Yes.
Okay.
Yes, thank you.
If you think you forget it, just write it down. Alt and the negative sign. MacBook is Control. It's Option. Actually, MacBook is Option and then the negative sign. Okay. Can I move on?
Yeah, I just want to clarify something.
Yeah, I'm listening.
Yes, so I just want to clarify. I think I had a small break in the network. So in terms of the objects, the H with capital letter, H with the small letters, and all keys. I think you were trying to explain something because of the network. I missed that briefly. If you can take it shortly. Sorry if I'm taking you back small. I think, yes, where your case is, I just want to get that explanation. Sorry for taking me down. Hello, please, you can hear me.
I can hear you, yes, I can hear you. All right. So what I was just trying to put across is that R is a case-sensitive software. Okay, R is very case-sensitive. You can't write goat with all small letters. You're going to be looking for that goat. Somebody is really making noise. Okay. So what I was trying to explain is that R is very case sensitive. What that means is that the way and manner in which you name your object, R expects you to reference the same format when you are calling the object. I gave you several examples. Age with a capital A, okay, which we run or which we assign 30 to, okay, 32. You can't go and be looking for, if this is the age you are looking for, you can't go and be looking for that age with capital letters. It will not work. For some reason, if there's another variable in your data set that is capital age, it means that if it is calculation you are doing, you have picked the wrong object because you fail to properly reference the object you have created. Again, what I'm trying to say here is that age starting with a capital A and age all lower cases, they are different things altogether. Again, with age with capital letters, they're different in altogether. So if you use capital letters, reference the capital letter when you're calling the object. But I say that let's not use capital letter in whether you're doing programming, statistics, all those things. Maintain your lower cases and also maintain the snake. And also maintain the lower casing, and then join it with the underscore. Isan, are you good?
Yes, thank you very much for that clarification.
All right. So many a times, I put my phone on do not disturb. Many a times, I learned this when I was learning Stata. At times, you want to run a model. And the model will not run. It will tell you that the model will just not run. And if you don't really read the error message carefully, you'll be wondering that the code I've written, the code is correct. You even go and research the code, you know that the code I have written is correct. But the reason why your model is not running is because you did not include or format your variable to the appropriate format. What I'm trying to say here is that these softwares that we use, they don't understand English. The statistical software that we use, they don't understand English. They translate what we understand as a male as 1 or as a number, and a female as 0. Those are they work with values. And because we are humans, and we need to read and understand. So this temperature, level of education, marital status, thing we see is for our own benefit. The software doesn't understand all those things. So for the software to be able to run with those characters, that's the software has to find a way to look at sex, male, female, as somehow numbers, okay? As somehow numbers. Because of that, you really need to understand the kind of data type you have before you go about trying to perform mathematical operations on them. For that reason, in this chapter here, we are looking at data types in R. The data types in R probably are different from the data type in Python, okay? Our next lesson will be in Python when I have time. The data type that you learn in R is different from the data type that is in Stata, and is different from the data type that is in Python. Fortunately for us, the type of data type we have in R are not that many. The first one is numbers. Okay, we call it numeric. R reference numbers as numeric. Okay, then let's do this example. So you have hemoglobin, okay, HB, you have hemoglobin. By now, we are expert in assigning values to objects. Hemoglobin is 10.5 grams per deciliter. We run it. Then you have body temperature, which is this person have high temperature, 39.1. And then the number of antenatal care visits. This person made at least 4 visits. So we assign this. You know that if you want to know what the hemoglobin for this particular person is, you just click on the hemoglobin because you have already assigned it. So this value, the value of 10.5 will be embedded in this object. So when you run it, you should get 10.5, correct? We have assigned this hyperparexia to the patient's body temperature, and this temperature is 39.1. So if you run it, you call that 39.1. The number of A and C visits, 4 visits, if you run it, you call the number of time this particular patient went for A and C visit. Now, somebody will be asking that, oh, Ken, how would I know that this particular variable is a numeric variable or this particular variable is a character, okay? In other softwares, we call them strange, especially in Stata. We call what are referenced as character as strange, like test values or test labels, so to speak. Now, if you really want to check the type of variable your variable is, you use the function called class. Okay? This class. Okay, what class is my variable hemoglobin? That is the question. What class is my variable hemoglobin? What do you think the class is? Anyone? Hemoglobin is what? 10.5. What do you think the class of hemoglobin is?
Number.
Okay.
Numeric.
Numeric. So let's run it and see. What do we have here? Numeric, right? We have numeric.
Yes.
Because it's actually numbers, it's numeric. So when we talk about numeric, it actually contains both decimals, and then what's the name? Integers. Okay. But other places, in other softwares, decimal is seen as float. We refer to decimals as float. But both decimals and then integers are seen as numeric. Keep it that way. That is why the number of data types you have to deal with in R is smaller, because other softwares expand them. They differentiate between them. And I believe that you agree with me that body temperature and the number of A and C attendants should also return numeric. Do I agree?
Yes.
We agree.
Yes.
So if you have your large data set and you want to see this particular variable, how is it stored? You call your data set and then reference the variable. And I'll teach you that. It's very sweet. You get to understand. Small. Now, we know that these are numbers or numeric variables. Now, if I say Amma, my patient name is Amma. Where is the patient coming from? Savelugu. The patient tested positive for malaria. And this, I know that. Let me explain something. If you are assigning a value or something to a container or an object, if the thing is a test, you double quote it. If the thing is a test, whatever you are writing, if it's a test, you double quote it. So R will understand that this thing that they are trying to assign is a test. Amma is a test. So you wrap Amma in double quotes. Do we get a concept? Hello?
Yes.
Yes. So Amma is a test. Savelugu is a test. Positivity. Positive is also a test. These are English words. So you put them in quotation, double quotation. Okay. So let's run them. Now, if you want to call, what is the patient's name? Amma. Which district is the patient coming from? Savelugu. What is the patient malaria result? The patient tested positive. Now, what do you think the class of patient's name is? Anybody?
Strength.
What do you think it is?
Strength.
Strange.
I like that answer. Anybody? Do you have any deviation from what the answer that they have given? The reason why the two gentlemen mentioned strange is because probably they are used to Stata. True or false? You've used Stata before, right?
Yeah.
Yeah.
Using Stata.
Exactly. That is why you mentioned strange, and I will not fault you for that. You have to understand that softwares look, there are differences in how softwares, like certain statistical softwares, name what you are calling even strange. The answer is character. Okay. Once you are coming from the Stata background where you are so sure that the answer is strange, here it's called character. Okay, so when I'm talking to you, I say, well, my variable is a character variable. You'll be asking me, what is character? What is character? Character is just strange, as you said, but in R we call it what? Character, right? So what is a class of patient name? Don't forget the patient name is quoted in double quotation. So this should give you, what are we expecting? My ladies. Character. Yes. So character. Okay. Character. And all these are, of course, characters. Okay. Let me quickly say something. The softwares hate characters. It will not run if you want to perform, let's say, logit model, this like regression models, you want to include this thing. R expects you to convert this character into what we call a factor variable. And when we get there, you understand. That is why you really have to know the class of the variable. And you understand if the class return character for you, then that will invoke your thinking that, okay, because R doesn't like to work with character variable, let me just convert this character variable into factor variable to make peace with R. Do we get it? That's why you have to understand the kind of variables that you have. Now you have something we call logical data. Logical data. Okay. The concept of 0 and 1, true or false, those are logic. Okay. Logic, true or false. These are logical data. So if we say the patient has fever and somebody responds true, the patient has fever, and the response is true, the patient owns ITN, and somebody say false. See, this false we have written here is not, R is not seeing it as English. If you look closely, you realize that there are certain reserved words. Anytime you type them, R colors them. So the class that you have written here, what it means is that these are reserved words for the R softwares. Anytime you type any reserved word that R knows, it will color them. So because R knows that, so you may be thinking that you're writing true as an English word, but these are reserved word for R for logical values, right? So if you assign true, if you type true, it will change color because R knows, okay, these are class of characters or class of writings that falls within R reserved words. So if you say has fever, the patient has fever, and you say true, whether the patient owns an ITN or not, you say false. In fact, you know that if you call has fever, what should you get? You get true. Owns an ITN, you get false, of course. But when you now check the class of the variable, you will see logical. Okay, let's see. Logical. And the same applies for class as well. Are we together?
Yeah, Kingsley.
Yeah.
Is our logical characters also case sensitive?
Of course, when you type, of course, it's a very good question because there are times that when we want to even calculate this, for example, mean, and our data contains, let's say, NA, okay, not applicable. We are expected to add certain argument to that. And so, for example, remove NA is equal to true. The question you ask me, if you go and type small true, even though it is true in your mind, even though it is true in your mind, R will not understand it to be true. So you have to keep the casing capital. These logical operators, these logical variable or values, you have to keep them capital. Please, anytime you're writing true in R and you in your mind, you think that is logical data you're writing, please keep it capital. Have I answered your question?
Yes, thank you.
Yeah, keep it capital. Anytime you're writing true or false in R, keep it capital. So we have logical. Great. Now this arithmetic operations. I wouldn't cover some of them. Now, when we say arithmetic operation, it's adding things, subtracting things, multiplying things, dividing things, and then exponentiating things. Okay, this I believe we all know from primary school. We all know this. So this is here so that you know that if you want to add something to something, you add plus. If you want to subtract, you add the normal minus, you know. If you want to exponentiate something, you use the symbol on top of 6. I think together with a shift, you click that, you press the 6, it will give you that symbol, that exponentiate. Now, what I want to bring your mind to is what we call the comparison operator. Okay, is this greater than this? Let me ask somebody a question. What do you think this will return for me? I'm doing comparison operation. 10 greater than 5. What will be the outcome? Anyone?
True.
True. Now look at it. True. True. So that is why it's a comparison operator. If, okay, 10 less than 5, what are we going to get?
False.
False. Now, this thing at times it confuses people, right? This is 10 greater than or equal to 10. What do you think you will get? 10.
False.
True.
What is the answer? Sister, what is the answer?
False.
True.
False.
True.
False.
Let's run
True.
it. Let's run it.
True.
True.
No, this is false. Mathematically, it's false.
This
It's
is false. It's true.
Yeah.
What is it?
True.
Say,
It's
No,
true.
it's false.
it's
It's
false.
false.
It's true.
It's true.
If you are to go by logical reasoning, it's false.
Let me
It's greater than or equal to. It's greater than or equal to. So it's true.
It's true.
No, 10 cannot be greater than 10.
You
That's
see,
that's why I say, if you are taking
Or-
logical reasoning, it's false.
Or equal to. 10
That is
greater
not
than or equal to.
equals
So
to.
it's either this or that.
So that's what I'm saying. The greater than, what's the name? Invalidates it. There is no way 10 can ever be greater than.
There is no way
So
10
what's
can, 10 can be greater than 10. That is why they limit it by the equal to. You understand? That is why they limit it by the equal to. So
okay.
let's understand this. The statement is 10 is greater than or equal to 10. First of all, 10 is not greater than 10, right? But it's limited that is equal to. The first part is not evaluated. The first one is invalid. 10 is greater than this. That is not true. But now it is equal to 10 is equal to 10. And that is what true. Here, 10 is less than or equal to 8. Now, what do you think the answer is? The answer should be false. Is that not so?
Yeah, false.
10
False.
is less than or equal to 8. This is clear. So this is false. 10 is equal to 10.
True.
10 is equal to 10.
True.
Now look at how we are applying the equals to. In your mind, the stator uses this and these are different. This is an assignment operator, which is equal to the single equal to is an assignment operator, okay, which is equal to this thing we've been doing. But this one is an evaluate. You are trying to evaluate if the sentence is true, okay. This is an assignment operator, okay. K is equal to 5. K is equal to 5. The single equal to is an assignment operator, but the double equal to is an evaluating operator, right? So you have to take note. So that's why you're saying that 10 is equal to 10, okay? And the answer is what? True. And then 10 is not equal to 5. The factorial and then equal to, so that is not this one. Shift and then 1 and then equal to, and this means not equal to. Do you make sense? This is what we used to represent not equal to. Does that make sense?
Yes.
Good. So 10 is not equal to 5. What's the answer? It should be true, right?
True.
True.
Yeah, true. Great. So these are comparison operators. You'll be using it a lot, okay? You'll be using it a lot. Now we have small example. Small example. We have temperature. The individual temperature is 35 degrees Celsius. 35 degrees Celsius. The person. Now, look at this. Fever, we assign temperature that is greater than or equal to temperature that is greater than or equal to 35. So this particular variable, right? This particular variable, fever, has values 37.5 ... So what? Infinity. Am I right?
Yes.
Let's think about it. We know that we have this particular variable that we are trying to create, okay? Object that has fever. Okay? If temperature, let's look at it this way. Look at it this way. I think, look at it this way. We created a variable, which is what? Temperature, which is 38 degrees Celsius. Now, what they are trying to say here is that, let me write it for you in English. The patient has fever, okay? If the temperature 38.5 is greater or equal to 37.5. Let me explain. Already, we have created this variable, okay, called temperature, 38.5 degrees. We have created this variable. Now, look at what they are saying. This is an evaluation, okay? What they are just trying to say here is that, what is the value? What value is this? Somebody should tell me. What value is this?
38.5.
38.5.
So they're just trying to tell you to evaluate this. Okay, let me use the pipe to separate it. They're just trying to evaluate whether 38.5, okay, is greater than or equals to 37.5. What is the answer?
It's true.
It's true, right?
Yeah.
So now look at this. So the outcome, that true would now be saved into this particular object, because this is a logical operation, right? Whether 38.5 is greater than or equal to 37.5. Are we getting it?
Yes.
Yeah.
If you don't get it, let me know. I will explain. Anyone? Good. Let me explain again. We have a variable that we call an object that we assign 38.5 to. So you know that anywhere you carry this object, it will spit 38.5 for you. Now, forget about this side first, okay? So we are saying that this 38.5, which we store here, so this thing I see here is 38.5, is greater or equal to 37.5. And that is true. That is true. So now the outcome, which is true, is now being assigned to has fever. So when you run has fever, what are you expecting to get? When you run this particular variable, what will you get? What will you get? True. True.
Yeah.
Yes, true.
Who doesn't understand? And I'm glad that some understood. Now let's evaluate the second one. Who can evaluate this for me? Who can evaluate it? Somebody should just evaluate it for me.
Let me try.
Please come in. Yes.
Okay, so hemoglobin, it's 9.8.
Mm-hmm.
So ischemic anemic, it's hemoglobin less than 11, which means it's 9.8 less than 11, which is true.
Okay. So you mean that when we now evaluate this particular variable, we should get what?
True.
True. Very well. Very good. Very good. I'm picking somebody at random.
Yeah, Kingsley.
So,
So does it mean the explanation, any patients that for less than 11, meaning the person is anemic, if I'm...
yes, if you are dealing with a whole data set, that is so you get that. If
okay.
if you are dealing with a whole data set, some people will not satisfy this condition. So you'll be getting true, false, true, false, true, false, true, false. People who fall within this particular operation or this particular definition, you get the true, true. And people who are outside. But this one is because you are just dealing with one person. That's why you just got a single response, because this particular person, 9.8 is actually less than 11. That's why you have the true return. Have I answered you?
Yes, sir. That's fine.
All right, I have a task for you. I need you to do this. I'll spell it out. I need you to do it. And if you're able to do it, then you know that you're getting somewhere. And this should take you 10 minutes. So this is a mid-session quiz exercise. The very first task, okay, so create an object called client age and assign it to 29. See if you can do that. Create an object which you call client underscore age and try to assign the value of 29 to it. If you're able to do that, you let me know. And this should take you less than 30 seconds to do.
Client age or client 8?
Look at it on my screen, client underscore age here.
Age. Can you give the instruction again, please?
Create an object, and that object is called client underscore age, and assign the value of 29 to that object. You've done the first task. Go to the second one. Task number 2. Create an object which is called client weight and assign a value of 64 to the client weight. Note that client weight is client underscore weight, all in lower cases. Client underscore weight, all in lower cases. That is task 2. Task 3. Create an object which is called client weight and assign 1.68 to it. Create an object called client height, and assign a value of 1.68 to it. Now, task 4. Let me mention task 4, and I'll wait for you to give me an answer before I go to task 5 and 6. Then we'll move on. Task 4. Calculate BMI and store it in an object called client underscore BMI. Is the instruction clear? Create a BMI or calculate BMI and store it in an object called client underscore BMI. Please do this. We have the weight, you have everything you need to calculate BMI. You have it already. So please do BMI for me. So it's 11:26. So 11 9:30. I should get an answer. That should be your, is it 9:30 or 9:30? I should get an answer. Please, so practice. Don't feel like I explain so you know. Just practice, because
BMI is weight over height.
you want the formula for BMI? BMI is equal to I say weight in kg divided by height, which is in meters square. Okay, so let's assume
So squared.
the weight that we have is in kg already, and the height is in meters. So the formula is BMI is equal to weight in kg divided by height in meters square.
Okay.
And you should know that you have to run those things at the object you created at the top before you'll be able to extract the values. If you don't run them, you will not get the values.
You said BMI is equal to?
The formula for BMI is weight in kg divided by height in meters square.
So
Yeah, Kingsley.
Yes.
So I just posted my answer if you can check if I'm right.
Okay, so they should finish and
On
then.
it. Yes.
It's good that you're writing everything. Yeah, I like what you're doing. Good. I think we should get our BMI by now, because this is something very simple.
my network was not good, so I didn't get the formula for the BMI.
BMI is equal to weight in kg divided by height in meters square. Weight divided by height.
Divided by height in meters square.
Yeah, divided by height in meters square. The time is up. Who has an answer?
22.
22.68.
22.
I mean 0.67574. Rounded.
Okay. What is the unit
22.
What's the unit of measurement for BMI? Because you just don't say 22. What's the unit of measurement for BMI? That is what
kilogram per meter square.
kg per meter. Good. So when you are responding to questions like this, don't forget to add the unit of measurement to it. So I have an answer for you. Let's see. Client age, client BMI. Let me run it and see. Let's assume I don't know. So let's run it and see. 22.67574. Are we good?
Yeah. Yeah.
Approximately 22.7, right?
Yes.
Yeah.
Yes.
Good. So you can clap for yourself. You've done well. You've been able to create an object and assign values to it, which I'm proud of. You've been able to do some small calculations by and let me see. I'm trying to mute somebody, so just I can't even mute the person. So let's go on. Let's go on. So like I'm proud of you. You've been able to create an object, assign values to it. You've been able to do one calculation, one small calculation. Now, you're not done. I want you to do something for me. Task 5. Create a logical object called overweight underscore check. This is it here. There's one thing I want to, we have created BMI, right? Now, I want to create an object which is called overweight underscore check. Like overweight check, okay? Overweight underscore check. That check whether the BMI is greater than or equal to 25. I want to see who will be able to do this. You have calculated the BMI already. Now I want you to create an object for me, and that object should be called overweight. Overweight, you are checking whether the patient is overweight. So the object name is overweight underscore check. Okay, that's check whether the BMI of the individual is greater than or equals to 25. I'll be very, very proud if you are able to do this.
Can you give the instruction again, please?
I will. Create a logical object called overweight underscore check. Okay, overweight, one word. Now underscore check. That check whether BMI is greater than or equals to 25. I will really, really be happy if you're able to do this. So, you know, to give you an apport, it will return a logical value, true or false. That's what it will return for you. And all these things come handy when you collect this measurement data, okay? Nutritional data, whether the child is stunting, all those nutritional measurements. You have to know all these things to be able to create cutoff points, okay? Whether the patient is stunting, whether the patient is this, whether the patient is that, whether the patient is obese, normal, overweight, underweight, and all these kind of things. Your knowledge in doing this, okay, will be important when you want to do something like that.
Kingsley, I've sent my answer.
You got your answer?
Yes.
Okay. So, okay, I've seen it.
Are we sending it to you personally? Or?
You can just mention it. Because I can't. What did you get? Can you confirm what the first person sent? Whether you agree to it or not?
Yeah, false.
You got false, yes.
Yes.
That is the answer.
I got false.
Exactly, that is the answer. And the code is written exactly as it should be written. But Joe, the code you sent to me, when the greater than equal to, like you have compacted everything together. I need you to write it like this. Let me just replicate the code you sent to me. You sent overweight check. Then you did your thing, and you said client BMI. Then you did this. You did this 25. You did this 25. Okay. Next time, please give it a space for clarity. Okay.
All right.
So that is a code, and the evaluation is false. You are right. The last task. Now, we have a patient that has a temperature of 38 degrees Celsius. Okay. A patient has a temperature of 38 degrees Celsius. Create an object called fever check. That check whether the patient has fever, use 37.5 as fever threshold. Yes. Somebody mentioned my name.
Let's say again.
Okay, I'm reading again. I need you. So the last task, we say we have a patient has temperature of 38 degrees Celsius. Do we get that? You have a patient that has a temperature of 38 degrees Celsius. That put aside. I need you to create an object which is called fever underscore check. Okay, that's check whether the patient has fever and use 37.5 as the fever threshold. I can continue to be reading it 100 times. I'm really happy that gradually we understand what we are doing. Small.
Kindly mention the threshold again.
The threshold is 37.5. 37.5.
Kingsley, but you said the patient has temperature of what, 38?
38, exactly. So now tell me whether this patient has fever or not. In code. I know you can read it and give me the answer, but give it to me in code.
Kingsley, you said has fever if the recording is greater than or equal to 37.5 or greater than 37.5.
So I don't want to give you the direct answer to what you're asking me. Let me read the thing for you again. Let's take time.
Okay.
A patient has a temperature of 38 degrees Celsius. Do you get that one?
Yes.
So I need you to create an object which check the patient, okay? An object called fever check. You got that one?
Yes.
That check whether this particular patient has fever. Now, for you to be able to know that you have to have something that you measure the patient's current temperature with, and that value is 37.5. Do you get the concept?
Yes.
We have a threshold. So from the question, I know that what the answer should return true. The answer should return true because already the patient has a temperature of 38 degrees Celsius. And they are saying that the benchmark is 37.5. So the patient temperature override or short the benchmark. So true, the patient has fever. I know you can read it and you can tell me, but I need this in code.
Okay.
Like you want us to say.
I need you to write it in code.
Should we send you the code?
Just write it, write the code, run it and see if it gives you the answer that you think that it is as you read the English. Because the answer should,
I have true.
You have true, so that is right.
Yeah. Also
But I had false.
You had false. Can you tell us
Yeah.
how you evaluate the whole scenario with the code, step by step?
Okay, I did the temperature
check,
which is 38 degrees Celsius, and I did fever check. Has fever 37.5.
Hold on, I like what you are doing. You did what? Temperature what?
The temperature first, then I ran it.
You did
the temperature is 38.0. Yes, and I did the fever check. And I assign
0. Then you have what? Fever
check.
Fever check, okay.
Yes, with past fever, which is greater equal to 37.5. Then I ran the fever check.
Okay, so let's try. Let me do it. So the temperature that we were giving 38. So temperature, and I assign the 38 to it.
Yeah.
Assign the 38 to it. Run. Then they say the benchmark. So temp bench. Okay. Bench.
Okay.
Okay. I'm not saying you should do it like this, but I want to break it down. What is the benchmark? 37.5, right? 37.
Okay.
And then the statement says that we should create an object called fever check. Fever check. Okay. And this should be evaluated. Okay. Create an object called fever check. That check whether the patient has fever. Okay. So a patient temperature, a patient has a temperature of 30 degrees Celsius. Create an object called fever. That check whether the patient has fever. So anything that should be, so we have temp, okay, greater or equals to the benchmark. If the temperature is greater, okay, it's not even greater than or equal to, because we have the, so the 37.5 is the threshold. So anything above 37.5 should be evaluated as what? The patient was having fever, right? The person who was talking earlier, the person who was guiding me through this.
Yes.
Are you understanding what we are doing? We said the benchmark, it means that when you're 37.5, it's not included in the fever. Do you agree with me?
Yes.
So that is a benchmark. Anything above that should be considered as fever. So now the temperature that the patient has, 38, is inside this one. Is this 38 greater than this? Let's run it. Let's run it. And if I evaluate her fever, I should get true. That's what most of you got, right? I think, let me see. Feedback is true.
Yes.
Yes.
It's true. Yeah, you can even read it and see it. It's just that I want you to know how to do it in code. That was why I put this. So the solution is there. Solution is under. Solution is here. So you see, the solution is here. Now, moving forward, let's look at what we call vectors. See, so gradually, you see, we started with just one numbers or one character, but gradually we are building on it. Okay. So there is something we call vectors. Vectors. So this vector stores like values. Okay, it stores data of the same type. What that means is that you cannot have a vector that will have something like 1, 2, 3 and have coffee inside. 1, 2, 3 have coffee inside. So a vector stores several values of the same type. Do we understand that definition?
Yes.
So meaning that if you are creating a vector for characters, everything should be character. If you are creating a vector for numbers or numeric, everything should be numeric. So what this is doing here is that, so vector, we use the C, which we call concatenate or combine, to hold the values together and separate them by commas. Let me explain to you further. Before we were just using 12, 25, assigning to age. But here we have several individuals in the data set now. How many do we have? We have 5. So we have ages. And then we assign. The first person's age is what? 12. Second, 25. Third, 30, 45, and 60. And we put them together by using this C, okay, the combined function. You see? So now, and then we separated them by commas. So if you run it,
but I feel like this one.
If you run it, and then you call the ages, you should have the values 12, 25, 30, 45, 60. Do you understand up to that stage? Here we have 5 individuals. Before we've been working with just one person. Do we understand?
Yes.
The same way, look at our hemoglobin levels for how many people? 1, 2, 3, 4, 5. So the person who is 12 years, this is the person's hemoglobin. The person who is 25, this is the person's hemoglobin. So we have hemoglobin levels or values which we assign. Don't forget that we are dealing with vectors, and the vectors are concatenated in like brackets. Many people are in the bracket, and their values are separated by commas. Don't forget. And if you return these, we have the hemoglobin levels of these 5 individuals. Okay. Now, let's look at the malaria status. Malaria status. The first person is positive. The person second is negative, negative, positive, and negative. Okay. So you have malaria status. It's a vector. We write C, the first person, comma, the second person, comma, the fifth person. Right? That we run it. And then we have the results spelled out on our console here for us. Now, fever status. The first person has fever. The second person doesn't have fever. Doesn't have like this. So 1, 2, 3, 4, 5. The 12th person, 10.5 positive has fever. We run it. So up to this side, if somebody doesn't understand, I need you to ask me a question. Let me address this issue before we move. Silence means you understood. That's great. Now we are moving into small statistics. Okay. Now remember that we have these ages of the individual. If I ask you they ask you what is the average age of your patients. We have 5 people in this in the ward. Okay, in the ward, and somebody comes and asks you, oh, doctor, this person, next this person, can you tell us the average age of your patient? Simply, average just means mean. Okay, so you just write mean and put the variable inside like this, and to give you the average. Look at it. What is the average?
34.4.
Is it difficult?
No.
It's not difficult. Now, if they ask you what is the median age of your patient, the English word.
Kindly redo what you did to get the mean, okay, please.
It's here. It's here. You can see mean. You open brackets. You put the variable inside. The variable we created earlier. The ages is inside, right? Do you get it?
Yeah. Yes, please. Yes.
Great. Now we have. If you want to find out the median, you have to find out the median. You just write median in English. Median is a function. Okay. You call the function, and which variable do you want to calculate the median on? And that is the age. And the age is a numeric variable. You know, you cannot calculate median on characters. You get an error. Median is a function. Then you put the variable, the numeric variable that you want to calculate the median on. Then you run it. So the median is 30. Okay. And then before we continue on, there are instances that you use. Somebody may ask, or people pick data sets when they are doing analysis because they are so used to mean, they just write data was collected with this number of with 200 sample. The average age of the study population is 32 point what years. You don't really do that just like that. You have to find if the data is symmetric. Okay, if the data is normally distributed. Okay, before you report the mean. And mostly, like in real life situations, we don't get that. Most of the data we collect in real life are skewed. And once your data is skewed, you are expected to report the median and the interquartile ranges rather than the mean. Think about it, even if you don't understand. The next time you're going to do any statistics and you want to report the mean, think about it. You have to find out whether your data is skewed, whether your data is symmetry, whether your data follow the normal distribution pattern. Okay, you can also perform other statistical tests, the SK test, skewness and kurtosis test, and all those kind of things to find out whether your data is in symmetry before you report the mean and the standard deviation. What that means is that if, let's say, 25 of us are in this class, and then I am 12 years, somebody is 13 years, somebody is 15 years, and then we have some old lady, which is 89 years in the class. If you run a histogram of that ages, you see that this particular histogram will be skewed to the right because there's somebody who is far 89 years in the class. If you calculate the mean, that particular person that is 89 years will pull the average up. So you are giving a wrong impression. Even though all of us are children in the class, because of that old lady, you are going to report an average age of something like 45 years. Because of that individual, the data is skewed. You didn't take care of it. So when you have a data like that, you report the median, okay? So we say that the mean is sensitive to outliers, whilst the median is not sensitive to outliers. Like, are we together? I just want to put this thing in your head so that the next time you want to report mean, you think about it twice before you do it. And when you report mean, you report the mean with the standard deviation. You report the median with the interquartile ranges, the 25th percentile and the 75th percentile. Now, if you want to find out what is the minimum age, the function is mean, okay, MIN. So the minimum age, you can see it from here that this is the minimum age. So it's reported for you. The maximum age, max, okay, maximum age, mass function, you bring the variable. You have the maximum, which is 60, is true. Because you have just 5 individuals, you can see if you have a data set about 1 million rows, okay, you see that this will come in handy. For some reason, I don't know why you want to add the ages of all your study participants, but if you want to do that, you just use the sum function and to give you, it will add the ages for you. So the addition of all these ages amounts to 172. 172. And finally, if you want to find out the number of people in your study sample, right? You use the length, and then you bring the ages. So this will give you 1, 2, 3, 4, 5. You should get 5. You should get 5. And all other calculations we did at the top, hemoglobin values, median, max, whatever. If I run this, if I run the course at the top, this should work. If I don't run, you should get an error. Okay, meaning I ran them before. So the median hemoglobin value, the mean hemoglobin value, the median hemoglobin value, the minimum, the maximum. Okay, and then some fever status. Okay, that gives you the summation of fever status 1, 2, 3. Are we together? Do we understand? If you don't, these are simple, basic summaries. Okay, and don't worry, all these things that we are doing one by one here, they're just commands to use to have all of them displayed for us, which we'll find out later. Are we together?
Yeah.
Yes.
Hello.
Yes, madam.
Please, why is the sum of fever status 3?
Let me see. Because it's counting the truths.
Okay, only the truths.
It's counting the truths, yes.
Oh, okay.
Are we okay? Are you okay? So
yes,
it's 11:55. I want to use 5 minutes to teach you missing values, okay? Then we can. Remember, I talk about factors along the way. I don't want to extend the time. Let me teach you missing values. Then we close. So the class will extend beyond the 8 weeks that I plan. So in real life, at times you go to somebody, you're asking them, you're doing a survey, you go to the person, what is your age? The person will be laughing and be watching your face. The person doesn't, Ghana, people don't want to give their ages. You ask somebody, what is your age? The person will not want to give you the age, especially women in Ghana. Oh, you don't know woman, you don't have to know a woman's age and all that. So this attitude or behavior would make you face a challenge of missing data. Okay. So most of the data we collect, especially ages, we don't really get the full ages of the individual. What I mean is that there are missing values. You get missing values in the data. Okay. Trust me, if you have missing, okay, R represents missing by NA, not applicable, NA, miss like that. If you run this command on it, this function on it will not work. And because it's a real life situation, I have to show you how to handle these issues. So by so doing, we are creating an object which we are naming HB underscore values with missing. It makes sense that we are creating a container or an object that should have HB of individuals, including those who did not report their HB status. So see, the first person is 10.5, the second person is 11.2, the third person did not produce his HB values. The fourth person did, and the fifth person did. So let's create that object. We created that object. Now, so here, this one, we should get an error. Why are we getting an error? Because there's a missing value in that particular, what's the name? That particular data, okay? There's a missing value inside. So when you run it, you should get an error. Okay, it didn't return anything for you. You have NA not applicable. So the average that you want, let me clear here and then rerun that thing so that you see that what I'm saying actually happened. See, it did not produce the mean. Why? So if we don't have this knowledge, you'll be saying that Kingsley told me that if I want to calculate the mean, I have to bring the mean function, open bracket, and put the variable inside. I did it, it's not working. The reason why it's not working is because there is an empty cell or an empty, what's the name? There's age is missing. There are some ages in the data set, whether it is 1, 2, 10, 100. There are not NAs in your age. That is why it's not evaluating. So in order to do that, you write the code. Look at it. Mean, okay? Mean, you bring a variable. Then you bring comma. Then NA, what is it? This is NA. You remove it, dot remove. You set it to true, meaning that remove the missing value from the data before you evaluate the mean. Does that make sense? NA.remove, NA.rm. And somebody was asking me, if I write true, does the true have to be capital letters? The true and false have to be capital letters all the time. So meaning that, okay, I have this object, but I know that there are missing values inside. So, and those missing values are represented by NA. So that NA, I want you to RM it, remove it, and then it's equal to true, okay? And then when you run this should work. Does it make sense?
Sir, my question is, I can see that the remove, the NA there is in small letters.
Yeah.
But the NA we see in the HB values with missing is capital letters. So
how is this so?
Yes.
Why do it's an argument. Look at this. Let me replicate this. Mean, then we have HB values with missing. HB values with missing. When I bring comma and I press tab, it will give me all the argument I'm able to use. And this is what we are using, okay? It's an argument. You have no control over it. So this NA, if you want to represent a missing value in a vector or in a data set, you use capital NA. You can't use small n here. It will not see it as a missing value, okay? In a vector, use NA. But when you are trying to remove that NA, like from a function, so here, I did something like this. So once you bring the comma, you press the tab. The value itself, the argument itself will bring you how it is written. NA, you just have to write the true to it, and then you cover it, and then you run your code. So it's a convention. There's nothing you can do about it. The capital NA represents missing values in a vector, and this is an argument, which is what? Small n and small a dot rm dot remove. You can't really do anything about it. You run it, you have your values out. Are you okay?
Yeah.
Yes, sir.
Good. Now, if you want to count, the final thing, if you want to count the missingness, the number of missing values. First of all, here, look at this. This is NA. Is telling you are asking whether there is a missing value in this data set. It's a question. It's NA. So what do you think you get? What do you think you get? It's either you get true or false, right?
Yes.
So meaning, what is it? So look at this. The first person is not missing. The third person is not missing. The first person is not missing. The second person is not missing. But the third person is missing. If you now want to count how many missing is in that vector, you sum it, okay? You sum it. You sum it. Then you call the is NA function again. So this is what you call nested function. This is what is happening. This is what is happening. See, we have is dot NA. That's the first function. Do you get it? That will return.
Yeah.
That will return. Then we have the sum. The sum. So if you are somebody who like coding, like you are chewing granules one by one, this is what you will do. We have you something like it's missing. It's missing. Okay, then you assign this to it. You see, this is NA. You see, it's NA. You assign to like this. This will return true or falses for you. Look at it. So if you call this, this should return true or falses for you. Now, because we have already done the is NA, if you want to count the number of missing, you just have to put, if you don't want to do the nested function, you have to put this one in the sum, okay? And then this one will give you the number of missing, right? So if you're afraid of nested functions, so what I've just done, look at it. Let's think about it very well. We have two functions. The first one is NA, will tell you this, that is missing or not missing. Now, if we value that one finish, now the second function will now take over and count the number of missing. Does that make sense? So if it's too much in your head, that was how I was able to break it down into two. First of all, is NA, I assign it to something. Okay, I assign it to something. I assign it to something. So this will give me the true, and then put it into X. And now I want to know the sum of. I want to know the sum of the X, which will give me the sum of the missing, which should be equal to 1. Any confusion? We are 4 minutes ahead of 4 minutes time. Any confusion? So I guess if there's no confusion, I guess that we are good. Any question before we close? And I'm stopping the recording here. If there's any further issue for us to discuss, we'll discuss it out of the recording. Stop.